now I'm going to hand over to Dr. Iredell.
Thank you. Make sure I can get everything up there. Perfect. Thank you very much. Well, firstly, let me, on behalf of RMIT, say how glad we are to host 3D Heals. We certainly want to encourage the growth of the industry and have been working on it, particularly through Professor Grant for, not sure how long, around a decade or
Nearly decade on.
a decade on pushing additive and its application to implants. But Milan's work is excellent and they're having a lot of impact, but there's quite a few other things happening as well, which I quickly want to take you through in the next 15 minutes. Just firstly, a little bit about how RMIT has organised its research. I won't go into this in a great deal of depth, but I'll touch on it. RMIT has decided it wants to make its research impact much more effective, and so it's focusing its research in 8 areas, only 4 of which I will mention today for shortness of time. Advanced manufacturing and fabrication, which I lead the platform. These are platforms, we're not the boss of any of them. We try to coordinate and facilitate research in particular areas. Rachel Crusoe, who's sitting in the audience here, leads the area on advanced materials. We have an area on biomedical health and innovation with Magdalena Levatsky, and obviously these 3 areas work very closely together, particularly in the implant and additive space. And then we have a series of others which we won't go into. By advanced materials, ECP, aim is to bring together experts, participants at RMIT to build, develop and grow industry links, harness their expertise and facilitating industry engagement and impact. And it's focused on 6 core areas, which for the sake of it I left that. Advanced materials is to build advanced manufacturing and fabrication industry that provides integrated customized services for objects. Like we want to go past just the object to the service, which is exactly where implants fit in. The biomedical and health innovation, ECP, is looking at critical areas of aging, population and urbanisation. That leads on to the particular diseases and conditions associated with those events. And to do that, understanding personalised medicine, bedside medicine, lifestyle, vaccine and drugs. So that's how we're implementing our research going forward at RMIT. Let's now talk about the areas associated with implants and generally additive manufacturing for biomedical applications. So what structures do we have? We have an ARC training centre in additive led by Milan, which brings together bioprinters, biolinks, clinical tools. It should be additive bio, I think there's a word dropped off there. We also have our Centre for Additive Manufacturing, which is also led by Milan, and you've been walking around it. We are now a partner with Swinburne and other institutions in SEAM. It's only about 1 week old. Surfaced enhanced additive manufacturing. So they're the 3, I guess, institutional structures that help us do our work. What work are we doing? Obviously, major focus on metallic implants, which you've just seen as you toured. Starting, this probably answers the question of, or this is Milan's work with 215 with the first 3D printed spinal implant produced by Atomics, and with a very nice design shape and getting the maximum strength from that complex shape. That sort of work still goes on well and is carried downstairs, but Milan's new driver is how do you make implants just in time? How can you produce the implant just when the patient needs it, just after you've done the surgery? So the major program is Striker at the moment, working out how to do that, how to design it, and how to get that high throughput worked out. We do a lot of work on titanium and a lot of different titanium alloys. We're also looking at new alloys for orthopedic and dental application. Zirconium is one of them. This is work done by Mark Green. Going out of the structural implants, we do a lot of work on metallic scaffolds. This is work done by Cooley Wad, looking at particular structures, particular geometries, and how we could design those geometries to give us enhanced manufacturability, strong biocompatibility, and a combination of biomedical topography processes. These are more titanium, biocompatible titanium alloys, and the novelty is in the innovative structures that she's developing. 2 or 3 good working on surface engineering for implants. Work done by Kate Fox, looking at diamond-coated titanium skeletons and seeing if you could get stronger biocompatibility with diamond coatings. And the initial results indicates that you probably can. Work done here by my colleague Zalbo, which is looking at how with strontium coatings we can change the balance between now, my pronunciation of medical terms is not great, oculoblast and oculoclast, change that balance depending on the nature of the coating to give better biocompatibility. Work done by my own team in conjunction with Cyro, looking at cold spray titanium tantalum coatings. The particular advantage of the cold spray of this is we actually do get particles of tantalum in the coating, and the hope is that those tantalum particles would promote better biocompatibility by allowing stronger cell growth on the tantalum. But it's not all about metallic work. There's also quite a lot of work on looking for scaffolds for cell graft. This work is done by Richard Williams. A lot of work looking at peptide-inspired structures, looking at microscale scaffolds for stem cells, looking at cross-link nanostructures for stem cell growth, and looking at if we can transplant those structures with the stem cells into the brain and promote neural regeneration. So that's just a very quick overview of some of the work done at RMIT. So we're going from the metallic areas to new metallic structures to actually use surface treatments for those structures to looking at scaffolding for stem cells. And there's more work that I didn't have time to cover in that quick 10 minutes. So very happy to chat to anybody, very happy also to follow our many inquiries to particular professors whose work I've highlighted. Once again, delighted to have you here, delighted to support 3D Heroes, and hope this will be part of the growth of our community. Thank you very much.